What's up, nerds? My name is Chisholm Nziako.
Hi, my name is Nisha Duby.
And I'm Marissa Nakagawa.
And we are the ones charged with turning you spineless biomators into fearless, confident, and knowledgeable soldiers of Alpha Rho fraternity.
Woo!
Today's your D-Day, your initiation, finally done. Time to conquer the single most prevalent problem anyone can face in the modern era, antibiotic resistance. Yeah, so much fun. Thank you. So today you'll be briefed and tested on the major components of our blazing passion for antibiotic resistance. Those who thrive shall be rewarded, while those who fail, let's just hope you get out of here without the bacteria getting to you first.
So, as you know, the overprescription of antibiotics has become a problem worldwide. Doctors may prescribe an antibiotic, it kills a great majority of the bacterial cells, but you may have a few left. They may have mutations that allow them to become resistant to the antibiotic. They replicate and they take over the patient. So what doctors need to do is find an efficient and effective method of treating these bacteria. A lot of these problems start in places like hospitals, where there's a large prescription rate of antibiotics, and oftentimes they can spread to the community.
Okay, awesome, guys. So now for the fun part, the testing. So your reward for a correct answer will be candy, actually, infused with only the finest antibiotics that a broke college student such as myself can buy. If fail to answer a question correctly, though, and you might get infected with the bacteria that we sprayed over all your seats before lecture started, so good luck, have fun.
All right, let's do this, guys. So, a classic freshman dilemma. The current ZOSI class was recently tested for this new bacteria that apparently spreads through mouth-to-mouth contact. It originated from the Sunday RPCC dim sum, and it's already spread to approximately 1/3 of the freshman class.
So gross, guys. What are you doing? Ugh.
So anyways, Cornell Health is currently executing an initiative to decrease the amount of antibiotics prescribed to students in an attempt to do even less work than they already do right now. So, to treat the outbreak of this freshman plague, they must determine how many bacterial cells were originally present. In one individual, they found that there were 10 to the 9th plague cells after 10 generations. So, how many bacterial cells were there originally?
Okay, discuss, guys. Talk to your neighbors. We'll be coming around with the mic, so yeah, you ready to answer? Discuss. Any volunteers think they can answer the question? It's chill, don't worry, I'll come find you. I bet one of you can answer this question. Oh, okay, cool, that works. Sorry, I don't know you, you're a stranger to me, Robert. Could you answer this question for me, possibly?
9.8 times 10 to the 5th.
Yeah, that's correct. So basically, you can model bacterial growth with an exponential function. You have the initial population, in this case, that's what we're solving for. You multiply it by 2 to the nth power, 2 being the base, because bacteria divide into 2, and n being the number of generations, in this case 10. Multiply them to get 10 to the 9th power. That's the current number of bacteria. And when you solve for the initial population size, you get 9.8 times 10 to the 5th.
Good, one question down, 2 more to go.
2 more to go. All right, so Cornell Health eventually found that penicillin was the best antibiotic for this bacteria, so they started distributing penicillin in a form of an expensive suppository. Because obviously no student in their right mind wants to take an expensive suppository, a cheaper alternative in the form of an edible candy containing kanamycin was sold on the streets of Tower Road. Why is this candy a bad idea? And in other words, how are the 2 different antibiotics different in treating bacteria?
Okay, discuss, guys. I'm going to come around and ask you, so no one is safe.
Okay, so you cannot necessarily substitute one for the other because they work through different methods. One works on the cell wall, the other works on the synthesis of proteins. So different bacteria may require either kanamycin or penicillin to be the most effective.
Yeah, that's awesome. Yeah. So basically, as you said, penicillin is a beta-lactam antibiotic, whereas kanamycin is an aminoglycoside. So as you mentioned, they both have different mechanisms of action. So beta-lactams work on protein formation in bacteria, whereas aminoglycosides focus on cell wall formation. Beta-lactams tend to help with a wide variety of bacteria, whereas aminoglycosides tend to be the most effective with gram-positive bacteria.
All right, good job, guys. So you guys made it to the last question. So, an overly drunk freshman was transported to Cayuga Medical yesterday.
Which was totally not me, because I was supposed to be preparing for this presentation.
Anyways, no, so he was exhibiting symptoms of this freshman plague. He said that he was taking the penicillin provided by Cornell Health, but he wasn't getting better. So we want to confirm that this is due to the bacteria actually becoming resistant to the antibiotic penicillin. After the freshman continued to drool, you collected some of that saliva, examined the bacteria, and through just diffusion method, you found that the zone of inhibition was irregularly shaped. And then, after performing the colony counting method, you realized that there are way too many colonies to count. What do you do?
Okay, discuss, guys. Last question. It's a doozy, so feel free to talk to your neighbor.
Last question, guys.
Okay, looks like we have a volunteer, guys. I guess,
So when the zone of inhibition is irregularly shaped, you take several measurements and then average them together.
Okay, so basically, yeah, just diffusion method and colony counting methods are some of the best ways to detect the efficacy of an antibiotic. So with the disc diffusion method, you spread the bacteria over agar, you take a disc, you dip it into a solution containing the antibiotic and place it in the center of the plate. You then wait to see the growth, and you can determine the diameters of the zone of inhibition if it's irregularly shaped and average those 3 lengths. In terms of the colony counting method, you integrate the antibiotic into the agar itself. You then spread the bacteria evenly across the plate, and then you have the colony formation. If there are too many, you can split the plate into 4 quadrants, count the colonies in 1 quadrant, and multiply that number by 4.
Awesome, congratulations. There's full-fledged members of Alpha Rho fraternity.
Woo!
I know, it's great, I know.
Victory Royale.
So although initiation was grueling and incredibly awkward for all of us, today you guys made it out alive, stronger than ever before. Today we simply addressed some simple issues regarding antibiotic resistance, but there's still a lot of work left to be done. So together we'll bring the world into a new modern era of science. So, all Alpha Rho guys, thanks for the time.